All right, welcome back, guys. So today I'm going to talk for just a little bit, and then the remainder of the time you guys can use to work. I just basically am going to do a couple more examples to illustrate applications of these transition matrices and such, and how to solve some different kinds of problems that you might encounter, say on the activities, activity 8.2 B especially. So I just want to walk through a couple examples, show you how it's done. And discuss some consequences and whatnot as we go. So without further ado, let's jump in. So let's look at our first example that I want to cover. This marker doesn't seem very good. Switch out here. Okay, so here's the situation in this example. We have a baseball player who is practicing his swing. So he's at a batting cage or something like that, right? And practicing his swings. And here is where the probability comes in. We're going to say that his success at hitting the ball is modeled by a Markov chain. And we know the following things. If he happened to hit the previous ball, then the probability of hitting the next one, he is, I want 3 times as likely to hit the next one as he is to miss. So he's 3 times more likely to hit the next ball than he is to miss it. And if he happened to miss the previous ball, then he is 3 times as likely to miss the next ball as to hit it. Okay, so here's our situation. And I'm going to end up asking several questions about this situation, but here's the first question that I'll ask. If he missed the last ball, what is the probability that he hits the third ball from now? So we just missed the most recent ball. What's the probability that 3 balls from now he's going to get a hit? Is basically what I'm asking here. Okay. And so we'd like to answer this question. And let's think about what we might need to answer this question. I'm basically asking about a transition from one state to another in terms of Markov language. What are the 2 states in this situation? Well, it's either he's going to hit the ball, he just hit the ball, that's a state, or the other state is that he just missed the ball. So those are the 2 states. There's hit or miss. And so I'm asking, what is the probability that he goes from a miss to a hit, or my words, from a miss to a hit after 3 steps, basically, right? So 3 steps, he goes from miss to hit. That's what we're asking for. And we know how to answer that kind of problem. We know that all we need to find maybe the 3-step transition matrix will get us. Or in particular, I need to find one entry of this matrix that represents going from miss to hit. But I need to find this at least, or maybe. Anyway, this would be the object that would give me the answer. So we need to find that. And to find that in the first place, I need to find the 1-step transition matrix first. And what is that? Well, I need to find the probabilities for going from one state to another. And we're not told them explicitly. Instead, we're told this information, that if he hits, then the probability, he's 3 times as likely as hitting it next time as he is of missing it. And if he misses, then he's 3 times as likely as missing again than he is as hitting it. So we need to translate this into numbers so that I can fill out our transition matrix. So we need to do that. And we've handled some problems like this before, but it's just there's a couple extra steps because we have these different situations that can arise. So let's see how this will work out. So first, let's find the matrix. Which means I need to find the probabilities. And there's 2 situations that are possible, right? He's either just hit the ball or he's just missed. So basically, I don't know what the probability of him getting a hit or a miss is in either situation yet. So let's translate this into some equations that I can solve to find the probabilities that I need. Let's let x represent the probability of getting a hit, and y will be the probability of a miss. Strictly speaking, these should depend on whether or not he just hit the ball or if he just missed the ball, right? And so we have two different situations. If the last swing that he took was a hit, what do I know? Well, I always know that x plus y equals 1. But in this situation, if he just got a hit, then I know that he's 3 times as likely to get a hit as he is to miss. So I know that x is 3y. So I could put x equals 3y as my other equation. So in the situation where he just got a hit, this is my system of equations that I get. And now I can solve this system of equations. So if I substitute in 3y for x, I get 3y plus y equals 1, which means 4y equals 1. So it looks like y equals 1/4, and x equals then 3/4. Just by solving this system of equations, I should get this. Y equals 1/4, x equals 3/4. So this is in the situation where he just got a hit. This is telling me then that the probability of getting a hit again is 3/4, and the probability of missing is 1/4. Okay? Now, the other situation is if the last swing was a miss, then what does my system of equations look like? Again, I still know x plus y equals 1 because they're probabilities. So they have to add up to 1. But now I know that instead, he's 3 times as likely to miss as he is to hit in this situation, is what we were told. So now I know that y equals 3x. Situation is reversed. I have y equals 3x. So what's that mean? Well, if I substitute this back in and solve, I'm going to find that x now is 1/4 and y is 3/4. And so here's my solution in this case. So I've now found all the probabilities in either situation. So that tells me that my matrix is the following. Tells me that well, here, I'll draw it over here instead. What I have found is the following. My matrix looks like this. It's a 2x2 matrix. If this is hit, miss, the probability of going from hit to hit was 3/4, and the probability of going from hit to miss was 1/4. Probability of going from miss to hit is 1/4, and the probability of going miss to miss is 3/4. And hang on a second. I need to... Okay. My cat sat on the keyboard. I need to make sure I didn't mess up anything. Anyway, okay, so here's our matrix. This is our one-step transition matrix. Now, we're interested in finding P3. We need the 3-step transition matrix. So what would I need to do? Maybe I need to find P2. That's just P squared. So I need to multiply this matrix by itself to find P squared first. So we know how to multiply matrices, so I'll just tell you what we get in this case. We should get the following. So you should try to work this out on your own and make sure your answer matches mine. You should get 5/8, 3/8, 3/8, 5/8 for P squared. Okay. And then now that I know P squared, I can find P cubed by just taking P. So P cubed is P times P squared. So I'm just going to multiply this matrix and this matrix. And again, I'll just give you the answer here. I trust you guys can work out the multiplication of the matrices. I should get 9/16, 7/16, 7/16, and 9/16. So there's some nice symmetry in these matrices here in this particular example. Okay, so here's my P3 matrix: 9/16, 7/16, 7/16, 9/16. Cool. So now we just need to answer the question that we were asked. And the question was, if our baseball player misses, what's the probability that he hits on the third, on the third guy from now? And so that is this entry here. I'll highlight it in red. That's his entry here. So our answer is 7/16. That's the probability. Okay. So we're able to get the answer just by finding this p to the third power and then looking for the appropriate entry. Okay, cool. So remember, using these k-step matrices are very useful when we're asking for probabilities involving going from one state to another after some number of steps. They're really good for it. They're basically only able to answer those kinds of problems. So let me give you a slightly different kind of question based on this same example, based on this exact same example. So here's another question I could ask. What is the probability, or I don't want to phrase it that way. I want to phrase it this way. If he hit the last ball, what is the probability of him hitting the next three balls? So assume that he just hit the ball. What's the probability that he'll hit all of the next three? So hit three more in a row. What's that probability? So you might think that we might want to use a matrix again or something. But actually, in this instance, I don't want to use the case a three-step matrix or anything like that. I don't want to use a transition matrix. Why is that? Well, the matrix, when I multiply out this matrix, it's giving me probabilities of transitioning from one state to another over the course of 3 steps. In between step 1 and step 3 or whatever, anything is allowed to happen. So it's taking a lot of different possibilities. All I know is that I'm going to start with a miss and I'm going to end with a hit. Anything in between could either be a hit or a miss. There's no specification in that situation for this matrix. But for this problem, I am specifying very specifically that not only is he going to get a hit on the first and the third or whatever, he's also going to hit it at every time in between. So there's a very specific outcome here. Namely, he's going to hit the ball every time from the first to 3 balls from now. He's going to hit it. So we can't really use a matrix here. Instead, we just have to be very straightforward and ask, well, what does the outcome look like in this situation? How could he get a hit and then hit the next 3 balls also? Well, what's that going to look like? It's going to look like this. Think of it like a tree diagram where you're going to map out the situation. He's going to start with a hit. And then what's going to happen? Well, he has to hit the next 3 balls. So the next ball will also be a hit. And then what has to happen? Well, the next ball is a hit. And then what has to happen again, because he has to hit 3 balls in a row after, he gets another hit. So the tree diagram for this situation really just looks like this. It's just a line. It's very boring because he's hitting the ball every single time. There's no variance allowed. And what's the probability? What probability should I label my arrows with? Well, we know that if he had made a hit, then the probability of getting another hit is 3/4. And so all of these get labeled 3/4. And since this is the only outcome in this situation that matches this criteria, this represents the whole this entire situation. And so I just need to multiply these 3/4, and that's my answer. I don't need to add anything up. I just multiply all 3 of these numbers, and I'm done. So the answer is just 3/4 to the 3rd power, because I have 3/4. And if you like, that's 27/64. Right?